Okay, our next example looks at a very common situation that we find ourselves dealing with in problems dealing with selling stuff, producing and selling stuff, and that is this demand equation. The basic idea is this: the price of an item, the price you charge for an item, is often connected with the number you sell. Right, lower price, you're going to sell more. Right, or alternatively, if you want to sell more, right, the price has to drop down. Right, sell more, price goes down. A very common idea. Okay, very common idea uh, all the time. Again, sell more, you have to drop the price. So they always have this type of relationship. Now, in this picture, it's a straight line, but it could be something more complicated, like a curve like this. It could be something more complicated like that, uh, and so on. Okay? So on. But this is called a demand equation, and we use these very often in these applied problems. As it turns out, from the demand equation, we can get some other information. And so that's what we're going to begin here is a problem where we're actually given information that lets us come up with this demand equation. Now, in this particular problem here, I've drawn the picture so that price is the y variable, number sold is the x. But we can sometimes be given demand equations where these two are reversed, but it doesn't change anything. It's still a demand equation, no matter whether it's solved for price or whether it's solved for number sold. You will actually see it in both situations. Okay, so we're going to be looking at a problem here that involves demand. Okay, so the problem that we have is going to begin with this information here. We know a particular business has determined that if they charge $16, that they're able to sell 200 toasters. If, on the other hand, they drop the price down to $14, they're actually able to sell 300 toasters. So our first question here is to find the demand equation. Now we're going to assume here that we're dealing with a straight line. Otherwise, we're not able to come up with the formula here. And so we know the price and we know the number sold. Now we're going to set this up so that P is the price and that X is the number sold. So X is taking the place of X and P is taking the place of the Y variable. And we want to find the equation of the line that satisfies this information. So selling 200 toasters, that's X, comes at a price of $16. And selling 300 toasters comes at a price point of $14. So since we have 2 points, we can now use that to come up with the equation of our line. We can now use that to come up with the equation of our line. So we do that. So since we have 2 points, we use our slope formula. That says the difference of the y's over the difference of the x's. And when we compute that, we get -2 over 100. But we would much prefer a decimal answer. So we find out that the slope for this one is -0.02. And then remember, we want to find the equation. we want to find the equation. So we go to our slope-intercept form, y equals mx plus b. Take our slope, negative 0.02, along with one of our 2 points. I'm just going to take the first one. Plug all that into our slope-intercept form for m, x, and y. Okay, so y is 16 equals negative 0.02 for m, 200 for x, and then we just need to solve to find the y-intercept. Solve to find the y-intercept. So what we're going to have here is 16 equals negative 0.02 times 200. So negative 4 plus b. So we find out that b is equal to 20. So now I can go write my equation out. Instead of y equals, I'm going to use p. P equals negative 0.02x plus 20. And so now we have the equation relating the price to the number sold. That again is called the demand equation. The demand equation. Now, when dealing with the demand equation, we need to know some constraints. Because how many things can people demand? Well, they could demand 0 things, of course, but demand is only going to work as long as the price is positive. So if we go back into our picture up here, right, we're only worried about the times for x where the price is positive. Right? If you have a negative price like down here, that doesn't matter. So we need to find out when the price would reach 0 for our demand equation, because that's going to be the cutoff. And we won't be dealing with demand anything beyond a price that's negative. So to find that constraint, we can make our price 0 and solve that equation for x. So here's a situation where we're actually finding the x-intercept, and it has a practical use because that's going to be the upper limit for our price for our x values. All right, because beyond that, the price will be negative and won't matter for our problem. All right, so we're going to solve that for x. So I can bring that 0.02x to the left side and then divide by 0.02 and get that 20 divided by 0.02 is 1,000. So the upper limitation for x is 1,000. Right, to sell 1,000 toasters, we need to set the price at $0. Right, anything beyond 1,000 would actually lead to a negative price. And of course, that doesn't make any sense. That doesn't make any sense. Okay. Once we have the revenue function, or once we have the demand function, we can then talk about the revenue function. We can then talk about the revenue function. Okay. Because revenue, in every situation that you're ever going to encounter it, is always quite simply the price you charge times the number sold. It's always going to be the price you charge times the number sold. So if we have the demand equation, the relationship here between the price and the number sold, whichever way that's written, this time it's written as P in terms of X, then we can substitute in for that one. We can take that p-value there, p equals that stuff, and go in here and replace our price with that expression. And that will give us our revenue in terms of numbers sold here. If it was the other way, we could get revenue in terms of the price. So here, revenue is equal to P times X. But we know P. We know P was a negative 0.02X plus 20. And then multiply that times X. So we get revenue here is equal to a negative 0.02 x squared plus 20x. And now revenue will have the exact same constraints that the demand equation had, which revenue is valid for any x value between 0 and 1,000 items sold. So now we have our revenue function. We have our revenue function. Okay. So we're going to continue next time with this problem and add a little bit more onto it. But for now, we're going to stop here with having just found our revenue function. And let's just very quickly take a look at the graph now of this revenue function. So first of all, let me just show you here the profit or the price function we just found. Y equals negative 0.02x plus 20. Almost looks like a flat line because I need to zoom over here on the x's because my x values again range all the way up to 1,000. So there's my price function. And then taking price times number sold gives me this function. Which looks like just two big vertical green lines, right? That's because I need to zoom up here on my y. Never let me get to just the y here. I'll show you. My price function really isn't helping much here. So I just got to pinch up here. And here's what we discover with revenue. Of course, if we don't sell anything, if x is 0, right, then we'd have 0 things times whatever price we're charging, which happens to be $20. We're not going to sell any toasters at $20, according to this model. We sell nothing, and of course revenue is nothing. And over here, if we sell 1,000 toasters, well, we'd have to set a price of $0. 0 times 1,000 would also give us a revenue of 0. And in this particular problem here, smack dab in the middle is the high point for this particular problem. Okay. But that won't always be the case when we're dealing with more complicated revenue or demand functions. But what I want you to see here is the revenue is just the price times the number sold. If we were to take this answer and divide all that by x, in other words, to get the average profit or the average revenue divided by number sold, then that would actually just take us right back to our price function. That would actually just take us right back to our price. So price or demand is actually the average revenue function. So we also have that connection as well. Okay, so we're going to stop with this example here, continue next time, and kind of wrap up this topic.